Hello everyone, how are you all? I hope all are doing absolutely great and amazing. And today we're going to discuss about the part 2 of thermal expansion, and today we're going to discuss about the expansion in liquids. Expansion in liquids. As you will know that the expansion property in a liquid is more than the expansion property of a solid, means the liquid expand more than the solids. Yeah, now another thing that we can know that the coefficient of thermal expansion, okay, but somehow we can do another thing with this. Okay, some basic things of this is, I think you can know that the rho means the density is equals to mass per volume. That is some basic things that I have tell. So there I will take a container. I will take a container which is filled with full water. The water level will be filled. Okay, so now one thing, that is in the expansion in a liquids, what we can know there have, we can see, is it a linear expansion, or is it the surface expansion, or is it the volume expansion? Yes, you can write that in the liquids there we can see that only the volumetric expansion, or you can say that the volume expansion. I mean here we will only use the gamma. Okay, so here I will write that the gamma final is equals to the gamma initial plus 1 plus what you can say that volume here we can use that the volume final is equals to volume initial into 1 plus rho delta T. Okay, volume final is equals to volume initial into 1 plus gamma delta T. Okay, I hope is it clear. Now that I will talk with next thing, that is I will take a container with fully filled water. Okay, now what I will do with the container, that is the temperature, that is T1, that is gamma, the coefficient of liquid expansion, you can use the volume of this is V final, and if I will give the temperature, that is T final, I will give the temperature, that is the temperature will be T final, and the volume, that is V final, but here there have no work. So what you can say that the mass of the water can change, you can say that, can you say the mass of the water is change, isn't it? मान लो at the temperature of 20 degrees Celsius the liquid has a mass of 20 kg, but at that 40 degrees centigrade the liquid has a mass of 40 kg, isn't it? Is it right? No, that is not right. We can find the density, means that is the rho and that is the rho final. Okay, what is the how we can calculate this? You can calculate the rho as rho initial is equals to the mass per what is the density? I have already write that mass per volume is density, so that is the P initial and P final. Hey, rho final is M by V final, that is V initial, and that is V final. Okay, I hope it's clear. Now one thing we're gonna do that you can write that I have already V final, right? V final is equals to V initial plus 1 plus V initial into 1 plus gamma delta T. So I will put it here, that is T. So I will write that M by V initial 1 plus, because V final is V initial 1 plus gamma delta T. Because why I will write this thing, because in the volumetric expansion we can know that the gamma is equals to V final minus V initial by V initial into T final minus T initial. You also can write here, that is, it also be written as the gamma is equals to delta V by V naught T. Okay, so hope this is clear. Now we're gonna discuss about if one thing, that is, so if the P final is equals to P sorry, that is not P, rho final is equals to, what you can say that the rho final is equals to rho initial by 1 plus gamma delta T. Okay, I hope it's clear. Now we can move that if the volume is increases, then what is in the density of the liquid is, if the volume will be increases, the density of the liquid is decreases, means inversely proportional. And same thing, if the temperature is increases, the density will be decreases. Okay, I hope it's clear. Now we gonna do that. A question. I will take a question, that is, hello, question number 1. I will take a cubic container, okay? I will take a cubic container which is fully filled with the water. It will be fully filled with the water. What you can do that, if I will give him the temperature, that is T initial, then what you can say that the volume, at first the there have this length is A. This length is A. There have the temperature of this is T initial, and there have the coefficient of linear expansion, the linear expansion, that is alpha. So here given that, and that is the gamma. So here given that the 3 alpha is gamma is less than 3 alpha, I mean 3 alpha is greater than gamma. Okay, and the T final is greater than the T initial. Okay, अब देखो इस सिचुएशन में क्या होता है, इस सिचुएशन में क्या होगा, इसके अंदर अगर इसके अंदर मैं हीट दे रहा हूं, मतलब क्या होगा, इसके अंदर लीनियर एक्सपेंशन होगा, मतलब ये जो पानी का लेवल वो घटेली की बढ़ेली घट जाएगा. ठीक है, the water level can decreases when I will give in the heat on it. Okay, the water level will be decreases. The level of the water is decreases. So what is the question then? What is the height of the liquid in the cubic container? Okay, so now what is the volume of this? We can find that the volume is a cube 1 plus gamma delta T. That is the volume of the liquid. Now the area of this, that is a square 1 plus gamma delta T into H. Okay, you also can write this is here and this is also here. Okay, this is a simple thing. I hope is it clear. Am I right this? No, that is not gamma, because there are says that is the linear expansion means there have 2 alpha. Because I say that a square into 1 plus 2 alpha delta T into H. Okay, I hope is it clear. So now we're gonna discuss about the volume, that is the volume of the liquid, and that is the area of this. So now after you can calculate, you can get the H. I hope is it clear. Now this principle will be worked on the thermometers. Okay, so put it on the principle of thermometer, that how the thermometer works. Here you can say that okay, imagine this is a thermometer. Okay, so this is fully filled with mercury. One noted thing, that is mercury, it has more expand property. Mercury has more expand property. Okay, so now what you can say that the area of this is V naught. Hey, sorry, the area of naught, this is the volume of this is V naught. This will be filled with mercury, and at the temperature of T initial, when the temperature rises, because of the mercury has a more expand property, because mercury has more expand. Okay, the mercury is more expand, so that the mercury will be used in the thermometers. Now they are also be written as the, that is of the glass, and that is for the mercury. Okay, and so what we can say that the V naught into 1 plus delta T minus the area of this is A minus V naught 1 plus gamma G delta T. That is, ये क्या है देखो, ये क्या है, ये जो इसका जो वॉल्यूम है, इसके अंदर जितना मर्क्यूरी है ये, और ये टोटल मर्क्यूरी. तो अगर इससे ये वाला माइनस हो जाएगा तो ये कहां पे आ जाएगा, हाइट पे आ जाएगा. और यहाँ पे ऐसे ऐसे क्या रहता है, मार्किंग रहते हैं, जो इतना ऊपर गया तो इतना टेम्परेचर. ओके, सो दैट इज इक्वल्स टू ए एच, दैट इज इक्वल्स टू ए इंटू एच. Okay, now there have the last concept of this is bind force. Okay, the last concept of this is buying force. How we can calculate the buying force? That is V rho G. V rho G. What is mean by this? V rho G. V is the of the body. V rho G is for the volume of the body. And the rho is the of the liquid. So if I will write that F force buying force final is equals to what? That volume of body, we can write this as the 1 plus B into 1 plus gamma delta T, isn't it? Now what is this gamma? This gamma is for body, okay, into the density final rho divided by what you can say that 1 plus rho. This rho is for the liquid, L delta T into G. This type of question means according to this concept there have some 4 questions of JEE Advanced and also JEE Mains. So you must do some question with the concept. Okay, so that is the concept of buying force. Now there have another. If the temperature is higher, then the buying force also be higher. Now there have another thing, that is last concept of today's video, that is the, we can know there have a thing that is gamma apparent is equals to the gamma, means here you can write gamma A is equals to the gamma, the gamma absolute is equals to gamma appearance plus the gamma of the material, the coefficient at the cubic expansion of the material, that is M. This is the thing. If I will that is gamma is equals to the change in volume delta V divided by V into V naught is the final initial temperature, T2 minus T1. So this is the concept. I hope it's clear. If it's clear, then thank you. Bye bye. See you. Take care of yourself. Stay motivated. Stay safe. Stay at home. And thank you for watching this video. If you are liking the video, then please share it with your friends. And don't forget to subscribe to the channel. Bye bye.